Hello, this is a workshop for heat exchanger, and in question number 4, I would like to ask you doing the heat exchanger analysis of HE1 heat exchanger type for these two streams under a constraint that pressure drop inside is equal to 5 in the tube side and 10 for the shell side. So let's go to put in fluid package. In this case, we have ethyl chloride solution and ethanol. So we can use like SRK in this case, and then we add the chemical into the system. Ethyl chloride. And then ethanol. Okay, we now to be ready for the simulation. Start with the flow first. This is going to be the mixture of ethyl chloride with ethanol. By the temperature of 200 degrees Fahrenheit, pressure of 35 psi. And the flow rate is based on pound mole per ounce, so we have to use the basis of mole flow. And in stream A, we flow with 100 pound mole per ounce of ethyl chloride solution, and then about 10. Okay. Now go for ethanol. With the temperature of 90 degrees Fahrenheit and 100 psia. And then the flow rate of only ethanol in 90 pound per ounce. Okay, now look like we're ready for the heat exchanger simulation. And let's use that and change that to the one that we're familiar with. Ethyl chloride mixture with ethanol go to the tube, while this ethanol go to shell. Then number 1 and number 2. Specification is that pressure drop in this equation is about 5 in shells in tube side and 10 on this side of shell. Okay, in this case, the model of heat exchanger that we will use to simulate as steady state leading. So according to this, alright, we go to the rating, and then we will work on this configuration. Okay, in this case, we consider the 1-1 shear and heat exchanger, or what we call is counter current heat exchanger, and it looks green here. So let's check for the performance. The performance says that Ft equal to 1. So the calculation should be nice. And when we look at the plot of the heat flow and temperature, you will see that the temperature, the energy flow in the tail side and to the tilt sides, not very close to each other. So this means the heat transfer is not very nice. So one thing that you have to do is go to find out for how much the minimum approach of this heat exchanger is. So you can go to spec and then add that. Find out for minimum approach using overall. And then the value telling that the temperature not very approach to each other. So heat transfer is not very nice. That's why what you get from the plot, is far away from each other. I will revisit this again for how to improve that. So let's try to another way on 2-2. Will be the same. Okay. That's when I use 1-2 shear and tilt heat exchanger, the Ft a little bit drop from 1 to 0.988, and the plot is still far away from each other. How about this minimum approach is 44. So heat transfer will not improve, cannot be improved by 1-2 compared to 1-1. Now let's go to the handout. The handout said that in case, is that possible to force this heat transfer to have minimum approach equal to 10? Okay, now let's do this. If I have that in the estimation number, okay, have that 10 degree Fahrenheit. So it means I need to do something, or I need to take this out. Okay. By changing that, the Ft go low. So let's see. This is the case of 1-2. The Ft is go low. How low it is? We have the Ft equal to 0.2, which is too low. The acceptable value should be higher than 0.75. So this is not good. However, when you go to see the plot of heat flow, it looks like the graph against the second law of thermodynamics, which cannot be made like this. They cannot cross to each other. So look like in this design, under 1-2, you cannot force the heat transfer have minimum approach equal to 10 degree Fahrenheit. So that's why we can go to the second case. In this second case, if I change this number to 40 degree Fahrenheit, okay, things will be different. Now let's see the graph. They seem to be okay. Get close to each other, but not very far, like previously. And when we go to when we go to see Ft is equal to 0.8. So in case of 1 to chill until heat exchanger, minimum approach of 40 degrees Fahrenheit is okay. We back to play around with delta. We back to go around with 1 counter current. See what happened. Okay. For 1 the plug is nice. How about the Ft equal to 1. This means that in this case, heat exchanger can be worked on only minimum approach is high, but not very much because this is 20 degrees Celsius and they still in the range of our study.